But don't act like a Italian enthusiast for asking questions. I'll look around the room and see if anybody would like to open things up. And Jeff, on his second to last day in his current role, you have nothing to lose. Over to you.
I don't know what you think of it.
It's going to be technical, isn't it?
No, I just don't know the slides. I think I did anyway, that the using the nuclear hydrogen is planned. It seemed like a few weeks.
Yeah.
So just why only a few weeks, and what what the barriers to making that time, extending that time, a much longer period.
So under the funding guidance, we have to. There's basic stipulations on how long the demonstration period should be. So we basically said it's designated between 4 and 8 weeks, but we do have the ambition afterwards to obviously commercially speak with EDF to try and extend that for a longer period of time. One other thing we are considering is whether we would potentially move the equipment to another site in the UK as well. So yeah, the demonstration is purely for the funding, but we have the vision to try and procure supply post demonstration. That makes sense. If it's successful, we'll show you.
So I suppose what I'm trying to get at again is like the current technologies, current production costs. Is that green hydrogen from each coming out to be a lot more expensive than other forms of low carbon hydrogen, or is it kind of like still on the side?
Yeah.
Yeah, so obviously this is just a 1 megawatt demonstration, so it's a higher cost than you could imagine if we did it at a bigger scale. The interesting question is the dynamics between producing power, selling the power, and using some steam to produce hydrogen. Because at 1 megawatt it's negligible. There is no impact on the output of the power station. If you want to increase the amount of steam that you take, you start impacting the amount of power. So there's an interesting dilemma in today's power price market. We're probably better off generating power. But actually, if you could produce the hydrogen at scale, it would start making it much more economic. So that when a market developed for hydrogen, it could wash its face.
Yeah, I think to touch on that, I think for the demonstration period, I think the costs are like 10 to 12 pounds per kilo. But obviously, the long-term goal, if we can get it to around 3 to 4 pounds a kilo, would make more commercial sense for us. But another piece of the project, which we've not yet worked on, is what the commercial value is of our low carbon or even our net zero products. So that's something which we're also working on as part of this project, is like a bit of a side project. We still don't understand that value. If we can pass a lot of the costs on to the customers, and the customers having to pay that for premium product, then yeah, our ambition would be to carry on 25 and onwards, keep operating.
That touches on the question I actually had it, just about the pressure you're seeing from your customers for low carbon products, and if that is your view driving innovation or just raising costs. Do you have any views on?
Yeah, I think it's definitely raising costs, and I think there is a struggle at the moment to pass costs on. Obviously, the economic climate at the moment doesn't look great. Our outlook for next year is not great in the construction industry, but I think there probably are certain customers out there that would pay the premium for the product. But yeah, passing that cost on, it is difficult. You've got to remember that we make high volume products at quite a low margin. So to pass even £1 a ton on, that's quite a large number. Obviously, that's an impact on customers overall. But I mean, the key message for us is, the fact that the project's backed by National Highways, which is a government organisation. The ambition there would be for them to want to pay more for low carbon or net zero actual products. That's something we've got to explore as part of the project.
As long as we've got car taxes. So we've got another question at the back. Yes, over to you, Mike. Thank you.
Can I just clarify before asking? So, if the hydrogen is going to get transported by truck to the site, so what would you equate that as in terms of like danger, in terms of other chemicals? Because one thing that's vividly stuck in my brain is seeing a hydrogen vehicle in America kind of set on fire was very, very dramatic. And so is there anything to sort of like quash those potential concerns around actually that transport as part of the whole system?
I think there's challenges around transport, but I believe the particular trays which we're looking at, they do fall under a certain regulation. So in terms of safety systems outside the site boundaries, they are all covered. I think the only restriction is around bridges and potentially tunnels. There are some travel restrictions there. Obviously, any haulier which we would choose to use, they would be au fait with obviously hydrogen transport logistics.
And it will be similar to sort of transporting petrol or something?
Yeah, it would, yeah, so they're not ordinary trailers, in fact, so there's innovation at each stage of the chain in this project. And the innovation around transportation is actually the use of this new technology type of trailer. Because it has to be a trailer that can cope with a high pressurization much beyond what we would normally pressurize for hydrogen transportation.
I mean, you've already got hydrogen containers on the road now, they're 230 bar, so yeah, all right, with slightly higher impression, higher volume, but yeah, I think safety implications are probably similar.
It's actually probably harder to make a case for the storage of hydrogen on the site as a nuclear power station within the site boundary. That's probably the harder case to make.
Yeah, I think you would probably want to move it as fast as possible off the site boundary. And part on the safety thing is part of doing the modelling is so that you can dynamically model startup and shutdown of these kind of systems, so that we can start to build a safety case alongside doing live demonstrations like the hydrogen. Yeah, I think transporting stuff like LPG is going to be comparable in dangers to hydrogen.
Okay, thank you. Any other questions? Yeah.
Quick question, Chris. Forgive me if I got the chemistry wrong, but it sounds really good that you're using, and it makes sense that you're using steam and electricity to make hydrogen. My understanding is that you need quite pure water to make hydrogen through electrolysis. Presumably, you get an added benefit with steam, because the steam is, I guess, purer than the water you start with.
Yes, there needs to be concerns, and that's part of HIAC. You need a supply of pretty clean water to just, the water's gone, you turn it into hydrogen. I never really thought about that, but that's true, that when you are vaporizing the feed to steam, you remove the any non-volatile impurities from it.
So my second supplementary is, could you use seawater? I mean, there is an issue with not having enough water, so is that a potential step that you could look at, is actually turning seawater into steam, leaving the bit of it behind, and that the steam, pure water would make hydrogen, so you get a double benefit for your bang for your buck.
I haven't thought about that, but sorry.
There's bound to be some
Potentially,
downsides in terms of corrosion.
corrosion in your heat
Well,
exchanger system. But if it's removed, that would be fine.
I mean, I do know during the feasibility phase, I mean, obviously it wasn't, it's outside boundary, but there were limitations on steam quality. So you have to also look at steam quality as well as the water quality.
It's the advantage of using steam as a nuclear power station as well, because that steam is, really high grade, high quality.
I mean, there are also nuclear plants around the world that are supporting desalination as well. So nuclear desalination is a real thing. I don't think we really explored it in the UK because there hasn't sort of been a need to because of our climate. I guess the other thing to consider is the steam that I think comes from the reactor doesn't directly go into the electrolyzer either. So there's a heat exchanger in the middle as well. So the purification of that water is still very important.
I thought there was a problem with lack of water at Sizewell, so...
Yes, so there's actually just been an announcement recently of where we will supply Sizewell C desalination plant with power from Sizewell B.
Interesting.
That was just announced last week.
I'm not exactly sure where it was, but some oil and gas facility in Aberdeen, and you think, almost the Highlands of Scotland is some of the most rainy place in the whole UK, but they still needed to truck in water recently because they didn't have enough for some of their processes. So paying attention to the water cycles also is really important as a question.
Very interesting. Any other questions at all? Yeah, okay.
Yeah, I just had one for Rachel. In your presentation, you showed that a quarter of the hydrogen cost is coming from the trucking. My knowledge is that that's basically unavoidable if you're using trucks. It basically comes down to the manpower. So, what is your thinking around as you scale up hydrogen production for customers, trucking versus pipeline versus co-location, and how that evolves?
I think so. You're right, and it's well picked up. And also the fact that we are actually transporting by road, of course, which hasn't gone unnoticed by us. For this type of demonstration phase, is the only option, and we all accept it. But I think there's, if we really look forward, co-location of technologies, that's the way ahead. That's where you can co-locate, green fuel production, perhaps desalination, hydrogen production, and power production, all in a nice, cohesive energy hub. That will get maximum efficiency and a cheaper product in the end. The idea of laying pipeworks to transport hydrogen as well, we looked at it briefly in the feasibility stage. It's way more efficient than transporting by truck if you go up to high volume. So yeah, that's the really great one.
I mean, we do see trucking as a potential in the future though, because we do have very remote sites that aren't grid connected, and they have no connection to natural gas as well. So.
But they could at least be hydrogen powered trucks.
Yeah, of course they could, yeah.
Being transported on net zero asphalt. Okay, thank you very much. Look around the room. Any other questions? And if not, are there any final comments? No, then I suggest that we'll call that a day, and we'll head downstairs. So could we show our appreciation for these panelists? And that was an amazing applause for the last session of the day. So thank you very much, everybody, for hanging around and being here for what's been a really interesting, insightful day. Thank you to all the presenters again who've given us their time to prepare and be here to present to you. Thanks to Eric for the organising and the invitation to ourselves to moderate the session today. And I think there's nothing else left to do but wish everybody safe journeys home, whether it be this evening or tomorrow, and look forward to seeing you downstairs. So thank you, everybody.